Okay, good afternoon to all. Okay, so it's 2:05. We'll start the class. Okay, so from today onwards, so you will have the unit test after 3:30 only. So generally, you will have 3:30 to 4:30. You will have the unit test. Okay. So in the previous class, so what we discussed means we discussed about the types of starters, types of induction motor starters. Okay. So what is the necessity of starter? What is the need of starter? And without starters, if we start means what will happen? So we discuss the need and necessity of the starters. Okay. So now there is a board தெரியுதா?
சொல்லுங்க சார்.
Okay, sir. Okay. So what is the need for starters? So we discussed that to limit the starting current, to avoid overload, and to avoid single phasing. So these are the reason for going for the starters. Okay. So we have the different purpose. One is to limit the starting current, to disconnect the starters, that is to disconnect the machine from overload, and to avoid single phasing. So can you anyone tell what is by single phasing? You know, overload, that and all. So new terms what we are using is a single phasing. So you know what is meant by overcurrent, what is meant by overload, everything you know. So what is meant by single phasing? சிங்கிள் ஃபேஸிங்னா என்ன சொல்ல ஏதோ சொன்னாதான் அப்புறம் சிஎல் எழுத முடியும். ஜென்ரல் கொஸ்டின்ஸ் கேட்டா அப்புறம் இப்போ நாட் ஏபிள் டு ஆன்சர். If you know means you can post in the chat box also. யாருக்குமே தெரியாதா? 66 பேருக்குமே தெரியாதா? 64 பேருக்கும். தம்பி யாராவது இருக்கீங்களா? கேக்குதா நடத்துறது? ஏதாவது ரெஸ்பான்ஸ் பண்ணாதான் நான் இருக்கீங்கன்னு அர்த்தம். எதுவுமே ரெஸ்பான்ஸ் இல்லைன்னா கேக்குதா கேட்கலன்னு எனக்கு தெரியாது.
வாய்ஸ் ஆடிபிள் தான் சார், அவனுக்கு ரெஸ்பாண்ட் பண்ண மாட்டாங்க.
ரெஸ்பான்ஸ் பண்ணலன்னா கிளாஸே வர தேவையில்லை எனக்கு தெரிஞ்ச வரைக்கும். ஏதாவது போட்டாதானே தெரியும். ஒன் ஃபேஸ் இஸ் ஓப்பன். ஓகே. Current flow in one neutral, one power line, power wire. So one phase is open is the meaning for the single phase. So in the three phase system, if you are having three terminals RYB, due to some situation, it may be due to loose connection, or due to failure of fuse, or due to failure of winding, any one winding. So then the symmetrical system or balanced system will be violated. It will comes to the unbalanced system because one phase is not available. So with the two phases, the induction motor try to operate means, so there will be a heavy voltage drop and we will have a overcurrent. So in order to avoid this means, we'll go for the starter. In some starters we'll provide with the overcurrent sensing element in terms of relay. So that will sense the excess current and it will disconnect the costly equipment. Which is costly equipment? Generally, motor is the costly equipment compared to the starter. So what is our objective? You have to protect the induction motor or induction machine from abnormal condition. So that is the main purpose of the starter. Okay. So if you are directly turning on, means so there may be a possibility you are not having any protection. The over voltage may be from the supply side, and the over voltage may be caused due to some internal problems, internal malfunctions. Similarly, over current may be from the input side or single phasing from the input side. So it may be any situation. It may be on the input side or in the machine side. You have to protect the costly equipment. Costly equipment is the operating equipment. That is our induction machine. So for this we are having different types of starters. Okay. So we'll have the two motors generally, squirrel cage and slip ring. So what are the starters we discussed? Okay. So we discussed about 4 starters. The starters which is used for the squirrel cage induction motor. So one is the stator resistance starter, direct online starter, auto transformer starter, star delta starter. So with the equations we discussed this 4 types of starters. Okay. So each and every starters will have some advantages and disadvantages. And DOL starter will be started without reducing the supply voltage. Because it is preferred for less than 5 kilowatt. So if the induction motor is having a capacity less than 5 kilowatt, they will prefer the DOL starter. And if you are having the induction motor capacity is more than 5, then we'll go for the stator resistance or auto transformer or star delta. Okay. So which starter is commonly used in the induction motor in case of squirrel cage? So we are having 4 different starters: DOL, stator resistance, auto transformer, star delta. So among these 4, so what is the type of starter we'll commonly used in the induction motor? You know the name of the starter? Which is having advantage, more advantage compared to the remaining starter. So I will give the clue also. Maintenance free. So 95% of the induction motor or a maximum induction motor will prefer this type of starter. What is the name of the starter? The maintenance is almost zero. In notes answer solirkalam. So having notes means you can advantage, disadvantage starter you can able to easily tell the answer. Which type of starter is commonly used, which is having maintenance zero among these 4 starter? இதெல்லாம் சொன்னாதான் அடுத்த ரோட்டார் ரெசிஸ்டன்ஸ் போக முடியும். இல்லை நீ புரிஞ்சிருக்க புரியலையா அப்படின்னு தெரியல. என்ன ஸ்டார்டர் வந்து காமனா யூஸ் பண்றோம்? Auto transformer. Any other answer? Auto transformer starter. So auto transformer starter. Any other answer? So auto transformer starter generally we'll use in the laboratory. That's okay. DOL starter. Then Ashwin, Venkadeshan. வேற என்ன இருக்கு? வேற ஏதாவது ஆன்சர் இருக்கா? ஸ்டார்டர் ரெசிஸ்டன்ஸ் ஸ்டார்டர் 3 ஸ்டார்டர் போட்டீங்க, இருக்கிறது இன்னொன்று தான் பேலன்ஸ். எனி அதர் ஆன்சர்? Auto. Okay, the exact answer is star delta starter. Okay, so the commonly used starters in the industrial area so will be the star delta starter, because it is having very minimum maintenance compared to the other types of starter. Okay, in laboratory we will use auto transformer than the auto transformer starter, but in the industrial area so we will generally prefer, because auto transformer is having a variac. So what will happen? Variac means if it is gets aged, and it is aged means it will have a gap between the moving contact and fixed contact. There is a possibility of spark. The weight of the starter will be more, okay, because we are using only the windings in the starter. So the auto transformer starter will be bulky, okay, it occupies more space. So that only will go for the star delta starter is having a miniature size, okay. So the commonly used starter is a star delta starter because it's having minimum maintenance compared to the other starter. The size will be very small, okay. So the commonly used starter in Kata, you have to write star delta starter, okay. So next we'll discuss about the rotor resistance starter, okay. So this rotor resistance starter is used for the slip ring induction motor, okay. So this is the actual what is the role, what is the advantage of rotor resistance starter means you can add the external resistance in the rotor circuit. In the case of squirrel cage induction motor, we'll add resistance or reactance or any ratio you will add in the stator side only. But in this case, in the rotor resistance starter, we'll add the external resistance. We have already resistance will be available in the rotor, okay. But in the case of squirrel cage, there you cannot able to add any external resistance. But in slip ring, we can able to add the external resistance. So how we are going to add the external resistance in the slip ring induction motor means through the rotor resistance starter, okay. So we'll have the arrangement of the starter will be like this, okay. So this is stator and this is the rotor part. So in the squirrel cage, what will happen? All these bindings will be short circuited, okay. But in the case of slip ring induction motor, we'll have this slip ring and brush assembly will be available. Through this slip ring and brush assembly, we'll add the external. So these external resistance will be available in the starter. So here we have the uniform variable terminal. Variable terminals will be available. So we have the rotor type arrangement of this starter. We'll have the points 1, 2, 3, 4 like that. We have the points. You can rotate that, and thereby you can select the amount of resistance, okay. And if we adjust these arms means external resistance can be included or it can be removed from the circuit, okay. So what will happen means during the starting condition, so this is the stator condition. You see the circuit diagram, this is input supply, this is stator, and this is slip ring rotor, okay. So this is the rotor winding RYB or A1, A2, A3 like that. You will have the 3 windings, and these 3 windings is not short circuited. In the squirrel cage, what will happen? These 3 windings will be short circuited like this. Remaining parts will be absent, okay. But in this case of slip ring induction motor, we will have a common point, and the remaining points it is of star connected only. The one end is short circuited, another end will be connected in series with the slip ring and brushes, okay. And again it will be connected in series with the external rheostat, okay. And if you keep this external rheostat at the maximum condition, you will include the entire resistance in the rotor circuit during the starting condition. So during the starting condition, the full external resistance will be included in the rotor circuit. And gradually, by using these switches, will move to the positions. You will gradually cut the resistance, and you will keep at the minimum position. Okay. Once if we keep them at the minimum positions, what will happen means it behave as a squirrel cage induction motor. Okay. So during the starting condition, you will include the rotor resistance. Okay. External resistance will be connected in series with the rotor circuit. So what are the elements available? We'll have a winding, we'll have a slip ring, brush, and external resistance will be connected in series. So when the motor attains 70 to 80% of the rated speed, then what will happen? You will short circuit the rotor circuit. You will remove the external resistance, you will remove the brush, you will remove the slip ring. So we'll have a mechanical contact. So that will remove this entire setup. What are the setup available? We have a slip ring, brush, and external rheostat. So this is all these 3 parts will be removed, and the rotor winding will be short circuited. Then it behaves during the running condition. It will behave as a squirrel cage rotor. So during starting condition, until it reaches the maximum speed. It will behave as a rotor resistance starter. Once the motor attains 80 to 90% of the rated speed, and this external rheostat, slip ring and brush will be removed from the rotor circuit, and the rotor will be gets short circuited. Okay. Then during the running condition, so the slip ring induction motor will behave as a squirrel cage induction motor. Are you clear up to this? So this is the special arrangement regarding the slip ring induction motor. So what is the need of this arrangement means? One is to limit the starting current, another to improve the starting torque. Okay. What is our objective means? In the squirrel cage induction motor, we have a low or moderate starting torque, and it is a constant speed motor, squirrel cage. But in the case of slip ring, if you use this rotor resistance starter, what is the purpose of this starter means? To limit the starting current and to improve the starting torque and to have the speed control. Okay. So by using these rheostat, you can have the speed control can be also be. You can change both the speed and the torque. Okay. You can change by using this external rheostat. So during the running condition, you can it can behave as a squirrel cage induction motor. It can behave as a squirrel cage induction motor. So this is the purpose of the rotor resistance starter. Okay. So in the speed control, we will discuss related to this. Okay. And what is the advantage of this starter means? You can list out these advantages. We can have a speed control. We can limit the starting current by adding the external resistance in the rotor circuit. Okay. You can improve. You can have a high starting torque. You can have a high starting torque. So in some applications similar to the series motor, so this slip ring induction motor will be used for the high starting torque application. Okay. So with the load, some applications will be used. So without load, you cannot be able to use that particular motor. So this motor is like similar to the motor used in lift, so elevator, hoist, in the traction train. So in these areas, we can prefer either slip ring induction motor or DC series motor. So these are the areas of applications of this slip ring induction machine. Okay. So this is the actually we are doing. Okay. How we are including the resistance and how we are cutting. These are the points we are having. Okay. So starting position and ending position. This is the start position. Okay. And so last will be the run position. Okay. So this point we will call as a run position. So during the starting position, this entire resistance will be included in series with the rotor. This is a rotor winding. Okay, a rotor resistance. So in series with this rotor resistance, this entire resistance will be included. So similar to 3-point and 4-point starter. Okay. So if you are at the during starting condition, so we'll have the A position. You can connect at the A. That is the start point. So all this entire resistance will be included in the rotor circuit. So gradually you can move the variac to the second. This resistance will be removed, and you can move to the third. This resistance will be removed, and if you move to the fourth, so this RX1, RX2, RX3 will be removed. And if you keep at this position means the total resistance, external resistance will be removed from the rotor circuit. Okay. With the RA or R2, with the R2, the motor will start to rotate. Okay. Or it will continue to run at the rated speed. So no external resistance will be available in the rotor circuit during the running condition. Okay. If we need speed control means again this resistance will be included. So for a specific application, if you want to do the speed control in the case of slip ring induction motor means, you will include this resistance. So during normal condition, if you want to operate the slip ring induction motor means it will behave similar to a squirrel cage induction motor. Okay. So any other doubt or any doubts on this topic? So this is the exact circuit diagram for the rotor resistance starter. Okay, you have to draw and you have to explain which how it is connected, and you can draw this diagram also and you can explain. Okay, so during starting condition, where will be the position of the switches? Okay, where the variac will be present. So we'll have a 3 variac will be available. Each and every phase will have a variac. Okay, and this variac will be varied uniformly only. Okay. It will be varied uniformly. Here, actually, this you have to draw here. So this ununiformly cannot vary on different phases. Uniformly you have to vary. உங்களுக்கு வேற ஏதாவது டவுட் இருக்குங்களா ஸ்டார்டர்ஸ்ல? So these are the starters available in the case of induction motor. Okay. So squirrel cage, DOL, stator resistance, auto transformer, star delta. So in the case of slip ring, we'll have a rotor resistance starter alone. Okay. In the rotor resistance starter, you draw these two and you can explain. வேற டவுட் இருக்குங்களாப்பா? So one more topic is available in this module 2. So that is a solid state starter. Okay, that we'll discuss on tomorrow morning. So if you are having any doubt means I will clarify. There is no doubt means we'll solve the problem on this starter. So we already derived the expressions for all the types of starters. Okay, so we'll try to solve the problem. Shall we move to the problem? Are you having any doubt on this rotor resistance starter? Okay. லைட்டாக தூங்காமல் இந்த அதுக்கு தான் ஆஃப்டர்நூனில் வந்து நம்ம ப்ராப்ளமாக சால்வ் பண்ணுறோம். ஓகேவா? ஃபுல்லாக சாப்பிட்டு வந்து உட்காந்துருப்பேன், அதனால லைட்டாக தூக்கம் வரும். ஸோ அதனால் வில் மூவ் டு த ப்ராப்ளம். So you take this 8th problem. To take this problem, we'll solve. So the ratio of maximum to full load torque in a 3-phase squirrel cage induction motor is 2.5. So calculate the ratio of starting torque to full load torque for a direct online starting. The rotor resistance is 0.5 ohm per phase and the rotor standstill reactance is 5 ohm per phase. So you write the given data. So what are the data given? So the maximum torque to full load torque is equal to 2.5. So calculate the ratio of starting torque to full load torque. So the starter given is a DOL. So DOL starter. So what you are supposed to calculate ratio of starting torque to full load torque for DOL starter. So the rotor resistance, so REA or R2, you can have a REA or R2. So you can mention R2 is equal to 0.5 ohm per phase. Okay. So rotor standstill reactance, that is X2. X2 equal to 5 ohm per phase. And you can write the starting equation, starting torque equation. So this already we have derived. Okay, K E2 squared R2 divided by R2 squared plus X2 squared. And next, maximum torque. So when you will get the maximum torque, what is the condition for maximum torque? This is the starting torque equation. So what is the condition? How will you get the formula for maximum torque? Means, so you know the condition R2 equal to X2. If you apply this condition here, means you will get the maximum torque equation. This and all we already discussed. Okay. So maximum torque equal to K E2 squared divided by 2x2. இந்த ஃபார்முலால நம்ம டார்க் ஈக்குவேஷன்ல டிஸ்கஸ் பண்ணிட்டோம். ஓகேவா? And what you are supposed to calculate means you are supposed to calculate starting torque to full load torque. Okay. This is a ratio you are supposed to calculate. So are clear up to this? These are the data given. So maximum torque to full load torque is 2.5. So the type of starter given is a dual starter. So you are supposed to calculate this ratio, starting torque to full load torque. You are supposed to calculate. Okay. And you know the starting torque equation and the maximum torque equation. Okay. And from this you can write the equation. So full load torque. So you know the how will you know this starting torque equation? You are supposed to calculate full load. Then if you calculate full load means you can take the ratio. So what is the full load? So from this equation you can write the full load equation is equal to so maximum torque divided by 2.5. Maximum torque divided by 2.5. So what is the maximum torque equation? This is the equation. Okay. You substitute the maximum torque equation here. K E2 squared divided by 2.5 into 2x2. So from this equation we are writing full load torque equal to maximum torque divided by 2.5. And you substitute the maximum torque equation here. K E2 squared divided by 2.5 into 2x2. And here you substitute the value. So K E2 squared divided by 2.5 into 2 into what is the value for x2? 5. And you substitute the value here. And then you will get K E2 squared divided by 10 into 2.5, 25. Okay. Are you clear up to this? So I will solve one or two problems, then you have to solve. I will give similar problem, so you can try to solve. Okay. So what is the next one means? So starting torque to full load torque. Because we calculate the full load torque, this is the full load torque value. So starting torque is available there. Okay. And you can take the ratio. So what is the starting torque formula? K E2 squared R2 divided by R2 squared plus X2 squared. And this is the starting torque. And what is the full load torque value? So if we take the ratio means the full load torque is K E2 squared divided by 25. So if you substitute means you will get to 25 divided by K E2 squared. And you cancel the common terms and substitute the value of R2 and X2. And you tell the value. So you can cancel these two terms. Then what is the R2 value? 0.5 divided by 0.5 whole squared plus 5 whole squared into 25. What is the answer? Okay. Abhirami, okay. The ratio between the starting torque to full load torque is 0.495. Okay, this is the correct answer. இதுல டவுட் இருக்கான்னு பாரு, அப்புறம் நெக்ஸ்ட் ப்ராப்ளம் சால்வ் பண்ணும்போது உனக்கு அப்புறம் டவுட்னு சொல்றது. So you should get to 0.495. So this is a ratio, so no need to mention any units. Units எதுவும் mention பண்ண தேவையில்ல. So you have to remember this equation. So this until we already derived. So starting torque equation and maximum torque. If you forget the maximum torque means you can remember this condition. Okay, R2 equal to X2. You substitute that condition means you will get this answer. Okay, so that is the maximum torque. Okay, shall we move to the next problem? நம்ம வேற ஏதாவது டவுட் இருக்கா இல்ல நெக்ஸ்ட் ப்ராப்ளம் போலாம். நாட் ஹேவிங் எனி டவுட். இப்போ ஒரு ஆன்சர் தான் வந்திருக்கு, மற்றவங்களாம் என்ன ஆன்சர் வந்துச்சா வரலையா? மற்றவங்களாம் சால்வ் பண்றீங்களா இல்லை காப்பியாவது பண்ண அப்புறமா கோத்ரூ பண்ணிக்கலாம். ஆர் கெட்டிங் எனி அதர் ஆன்சர் அதர் தன் திஸ் 0.495 இல்லாமல் வேற ஏதாவது கிடைக்குதா? தினேஷ்குமார், சேம் ஆன்சர். அதான் ஒரு 4-5 பேர் தான் ஆன்சர் பண்ற. ரூபன், அபிராமி, ஜீவிதா, அஸ்வின், வெங்கடேஷ், ஹரிகரன். இந்த தினேஷ்குமாருக்கானா? கிஷோர், தினேஷ்குமார் இல்லையா? 109. So 109 ஆப்ஷன் போட்டுடலாம், ஒன்றும் பிரச்சனை இல்லை. ஓகே, we'll move to the next problem. So you take the next problem. Determine approximately the starting torque of an induction motor. IM you take as induction motor. So in terms of full load torque, when started by means of star delta switch, that is a star delta starter. Second, as a auto transformer with 50% tapping. The short circuit current of the motor at normal voltage is 5 times the full load current, and the full load is 5%. So neglect magnetizing current. So you take down the problem and you write the given data. So here what you are supposed to calculate, you write. So in the given data, you write all the parameters and what you are supposed to find. That also you have to mention. So you are supposed to calculate starting torque to full load torque. Okay. So this you are supposed to calculate. Okay. And what are the starters given? Star delta starter. Second, auto transformer starter. In the auto transformer, we are given one data 50% tapping. So tapping is 50%. And slip value is given as a 5%. So full load slip at the full load is given as 5%. Next is short circuit current of the motor at the normal voltage is 5 times the full load current. So short circuit current, so you can consider IAC is equal to 5 times the IFL. So these are the data given. So you are supposed to calculate starting torque to full load torque for star delta starter and auto transformer starter. Okay. And you know the formula for star delta starter. You can write this formula. Okay. So if we consider the first type of starter, so star delta, so we will have the formula starting torque to full load torque is equal to 1 by 3 to IAC by IF whole squared into SF. Okay. And you can consider this only we are going to calculate the starting torque to full load. So what is the ISC value? 5 times the IFL. Okay, 5 times the IFL. So this is the IFL only, full load current into slip. Okay, and you substitute means you get the answer. So this is a direct substitution. You can substitute and you can tell the answer. And here you can substitute like this. So 1 by 3 into what is IAC? 5 into IFL divided by IFL whole squared into what is SF? 0.5. So tell the answer. $41.6. Okay, that is 0.416. So you can write this as a percentage. So 41.6 or nearly equal to 42. So you give the answer in terms of percentage. Okay. Okay. Okay, all the answers are correct. Sumant Reddy, Dinesh Kumar, Ashwin, Venkatesh, Janani. Okay. So similarly, you try for auto transformer starter. So again, you write the equation. So starting torque to full load torque is equal to here you will mention x squared into IAC divided by IF. That is a full load into SF. And what is this x value? That is the transformation ratio. You tell that as a k in kodum sollalam. You can tell as a k or x. You can mention as k or x. So both are same. So what is the k value given? 50%. So here you can consider k or x is equal to 50%. So that is equal to 0.5. So that is the small change in the auto transformer starter. So in the star delta starter, you will get 1 by 3. So in the auto transformer starter, we will get x squared. Okay. So x squared will have this tapping ratio 0.5. Remaining things will be same. So you tell the answer for auto transformer starter. Again, here you substitute this IS equal to 5 times the IFL and you cancel the IFL. You can mention IF here. Load. So what is the answer? So as per this equation, you can substitute 0.5 squared into you substitute that value 5 into IFL divided by IFL squared into 0.05. 10%. Any other answer? %31% is correct. So we'll get 31%. Starting torque to full load torque. So you will get the answer as a 0.31 only. Okay. You multiply that by 100. So you express in terms of percentage. Okay. You will get only 0.3125 only. So you can multiply that into 100. Okay. Okay. Sumant Reddy, Abhiram Venkatesh. Okay. Good. ஏதா டவுட் இருக்கான்னு பாரு. இப்போ நம்மளுக்கு CA2ல you will have this portion. Okay. So you will get the questions. Compulsory you will have the problem. Okay. So one theory question, one problem you will get. So what are the problems generally we are solving in the class will be available in your CA generally. So one or two questions, if it is a competitive exam question, means that we may solve some problem or we may not solve. Okay. So maximum we try to solve the NPTEL questions and GATE questions also. Are you clear? Means shall we move to the next problem? So next I will give only the question, you try to solve, and if there is any doubt means you may ask. Okay, because I will give the similar problem only. So what about remaining members? Are you following? Are you having any doubt? Some 4 or 5 members they have already completed and they posted the answer. So remaining members are having any doubt means you can unmute and you can ask the question, or you can put in the chat box also. If you are not asking anything means we will assume that you are clear, everything is clear. Okay, no doubt, Ashwin. Okay, okay. So shall we move to the next problem? So you try to solve this problem. So I need only the answer. So you can refer the previous problem. Same method you can follow this problem also. Okay, a 3-phase squirrel cage induction motor takes a starting current 6 times the full load current. Find the starting torque as a percentage of full load torque. The motor is started by D-oil starter, first subdivision, second through star delta starter. The full load slip of the motor is 4%. It is a 0.04. You solve and you tell the answer. So that is starting current is called as the short circuit current. Okay. So starting current is 6 times the full load current means so we have to assume so IAC equal to 6 times the IFL. So instead of auto transfer starter, here a DOL starter is given. You should know the formula for DOL starter. So this is the formula for star delta. This is the auto transformer. What about DOL starter? Formula for DOL starter. I'll write the formula for DOL starter. So DOL. So starting torque to full load torque is equal to IAC by IFL whole squared into SF. So this is the formula for DOL starter. So tell the answer. Okay, 1.44. Okay, correct answer, Abhirami. அது 144% போட்டுருங்க அவ்வளவுதான். For DOL starter, you check are you getting this value 1.44. So this will be can in terms of percentage means 1.144%. Now what about star delta starter? 48%. Okay, correct. So star delta starter, you check So are you getting 48%? So in the D volt starter, you will not having any constant because they are not reducing any voltage. Okay, they are not reducing any voltage in terms of tap setting or in terms of phase voltage to line voltage. No conversion is available in the case of D volt starter. So you will get here there will not be any X or any constant value or any ratio will not be available here. Okay, so directly starting torque to full load torque equal to short circuit current divided by full load current whole squared into SF. So if it is the stator resistance starter or auto transformer starter, you will get this same formula. You get in the stator resistance starter, you will have in terms of resistance ratio. In the auto transformer starter, you will have in terms of reactance. Okay. So in the case of star delta starter, you will get 1 by root 3 whole squared. So that we are having 1 by 3. So you should be clear with this formula. If it is a stator resistance starter means you will get the same formula. This formula is applicable for both stator resistance and auto transformer starter. Okay. So remember this formula. This formula, same formula will be repeatedly will be using. So shall we move to the next problem? Kavin irkepa 117 18E 117 Kavin K. பாதி பேர் லைன்ல இருக்க ஆனா எங்க கவனியா என்னன்னு தான் தெரியல. ஏன்னா கூப்பிடுறேன் எவனுமே பேச மாட்டேறே. தினேஷ்குமார் 109 கவின் 117 நீ பேசலாம் நான் ஆப்ஷன் போட்டுருவான். நீங்களா வந்து பிசிக்கலி யூ ஆர் பிரசன்ட். ரூபன் இருக்கேப்பா? ரூபன் ஓகே. நெக்ஸ்ட் ப்ராப்ளம் போயிடலாமா? ஆர் யூ எனி டவுட்?
நோ டவுட் சார்.
ஓகே, நீ ஆன்சர் பண்றவங்களே கூப்பிட்டனா தெரியாம. ஓகே, வில் மூவ் டு த நெக்ஸ்ட் ப்ராப்ளம். டேக் திஸ் ப்ராப்ளம். இந்த ப்ராப்ளம் சால்வ் பண்ண முடியுதான்னு பாரு, ட்ரை பண்ணு. The ratio of maximum torque to full load torque so in a three-phase squirrel cage induction motor is 2.2:1. 2.2:1. Determine the ratio of actual starting torque to full load torque for direct online starting, star delta starting, and auto transformer starting with the tapping of 70%. So rotor resistance and standstill reactance per phase are 0.5 ohm and 5 ohm respectively. ஃபார்முலா வந்து நீ தான் கண்டுபிடிக்கணும். நம்ம தான் ரெண்டு மூணு ப்ராப்ளம் சால்வ் பண்ணிட்டோம்ல. இப்போ என்ன கால்குலேட் பண்ண சொல்லியிருக்காங்க பாரு. ஃபர்ஸ்ட் யூ ரைட் த கிவன் டேட்டா. ஸோ மேக்ஸிமம் டார்க் டு ஃபுல் லோட் டார்க். மேக்ஸிமம் டார்க் டு ஃபுல் லோட் டார்க் வந்து என்ன 2.2. 2.2 is 1 இல்லையா? ஸோ மேக்ஸிமம் டார்க் டு ஃபுல் லோட் டார்க் வந்து ஈக்குவல் டு 2.2. அது ஏறிக்கும். Determine the ratio of starting torque to full load torque தான் calculate பண்ண சொல்லியிருக்காங்க. What are the different types of starters available? 3 volt starter இருக்கு, auto transformer and star delta. ஓகேவா? So you write the formula for starting torque and maximum torque. அந்த ஃபார்முலாலாம் எழுதிட்டே வா. அப்பதான் நீ full load torque calculate பண்ண முடியும். You write all the formulas. Okay. So starting torque formula எழுது, maximum torque formula எழுது. Generally you can take the ratio. You first of all calculate full load torque. You can refer the first problem. So in the today's class we solved one problem like this. Okay, you can refer the problem. So last problem you can for example 8, you can refer the problem number 8. So this we solved for direct online. So you can follow this problem. So afterwards you can include star delta and auto transformer. So you can refer the first problem in today's class. பார்த்தீங்கன்னா உனக்கு ஓரளவுக்கு ஐடியா கிடைக்கும். First you tell the answer only for detail. Remaining things I will explain. So if you refer the first problem means you will get the answer for D volt starter.
Sir, extra value na sir, X2L.
X2L ஓட வேல்யூ தான் 5 ohm கொடுத்திருக்கமே. R2 ரெசிஸ்டன்ஸ் வந்து 0.5 ohm.
Yes sir.
X2 வந்து 5 ohm.
K E2 square by 22 sir.
K எல்லாம் கேன்சல் ஆயில்லையா? K E2 எல்லாம் கேன்சல் ஆயிடுமே. ஃபர்ஸ்ட் ப்ராப்ளம் பாரு நல்லா. ஃபர்ஸ்ட் ப்ராப்ளம்ல E2 K எல்லாம் கேன்சல் ஆயிடும் பாரு.
Sir இது full load torque மட்டும் சொல்றேன் sir.
இது full load torque சொல்லு. Full load torque னா
K E2 square by 22 sir.
Yes sir, correct. Okay. So you can refer this formula. இது மாதிரி சால்வ் பண்ணிருப்பேன். K E2 squared divided by R2 so DOL so 0.04 0.43 வருதா? வேலிடேஷன் கொஞ்சம் செக் பண்ணுங்க. So maximum torque K E2 square divided by 2x2. இந்த ஃபார்முலாஸ் ஃபர்ஸ்ட் ப்ராப்ளத்திலே கொடுத்தாச்சு. So maximum torque to full load torque here it is given as 2.2. 2.43 na correct. So So from this you are supposed to calculate the full load torque. Then the full load torque வந்து calculate பண்ணணும். Maximum torque formula is available here. So maximum torque formula you know, and 2.2 you know. So calculate full load torque. So full load torque will be 43%. Starting torque to full load torque is equal to 40 volt starter. So starting torque to full load torque. So you'll get 0.4356. So this you can write as 43.5. So if you try to solve means, so you'll get full load torque is equal to maximum torque divided by 2.2. What is the maximum torque value? K E2 squared divided by 2x2 into 2.2. Okay, so you substitute the value of x2 value is given as 5 ohm. Again you can rewrite K E2 squared divided by 2 into 5 into 2.2. So you will get K E2 squared divided by 22. Then you are supposed to calculate the starting torque to load torque. So you calculate the full load torque, then you calculate then you can calculate this ratio. So starting torque formula is available, K E2 squared R2 divided by R2 squared plus X2 squared into, so 22 divided by K E2 squared. So cancel the terms, you will get that answer 43%. Okay, va? So next starter, are you having any idea how to calculate star delta starter? So star delta starter, you are having this formula. Okay. Are you having any idea how to solve this problem? Star delta starter, if you know the star delta starter means you can easily solve the auto transform starter. So you can consider, உங்களுக்கு ஐடியா எதா இருக்கா? Next we are going to solve for the star delta starter. Here you are supposed to calculate starting torque to full load torque தான் calculate பண்ண போறோம். So again you write the K E2 squared R2 divided by R2 squared plus X2 squared. What is the full load torque? Full load directly you can write 22 divided by K E2 squared. Okay. So this is a full load torque. This is a full load torque, and this is a starting torque. Okay. This is starting torque equation. This is a full load torque equation. So in this you have to do small changes with respect to the starter. So first we calculated for the D volt starter. So D volt starter directly you will have the same formula only. But in the case of star delta starter, what is this E2 squared? Are you having any idea? What is the E2 squared? What is the E2 squared? So this parameter is going to be varied with respect to different types of starter. So what is the E2? E2 is the amount of voltage available on the rotor circuit. It indirectly related to the voltage. Okay. So this E2 is indirectly related to the supply voltage. So in the case of star delta starter, you are going to reduce this voltage only. You are going to reduce. If it is auto transformer starter, what is our objective? You are supposed to reduce the voltage during the starting condition. So in the D volt starter, you will apply a full voltage. Okay, we will apply the voltage, and full voltage will be applied to the stator circuit. But in the case of star delta or auto transformer, so this E2 will have a ratio. Okay, So we'll apply the reduced voltage. What is the parameter? We will divide by root 3. Okay. 1 by root 3 times will reduce the supply voltage. So you can write here E2 divided by root 3 whole square. This is 1 by 3. So E2 by 3. You can simply you can write E2. So rotor voltage you are reduced by 3 times. Okay, you are going to reduce the voltage by 3. Okay, 1/3 you are going to reduce. So in the place of E2 squared, you have to substitute this value E2 divided by root 3 whole square. And if it is an auto transformer starter, so what is the tap setting given? 70% it is given. Okay, this is given as a 70%. So in that you have to substitute 0.7 E2 squared. Okay, so this small changes you got to do. Okay, if the R2 value, X2 value, E2 value is not given directly, it is not given means. So if it is a D volt starter, you will have the same formula. Okay, and if it is a star delta starter, you have to divide this voltage divided by root 3. And if it is auto transformer starter, you have to multiply this by percentage. What is the percentage given? 70%. So 0.7 into E2. This is the amount of voltage we are reducing by using the starter. Okay. So if it is a 60%, you are including 0.6. If it is a 30%, 0.3. So you will have the range of voltages in the case of auto transformer from 1 to 0 to 1. So this is the variation. Okay, and that will represent as a 0 to 100. So here we are representing in terms of value 0.7, 0.6, 0.65. Here we will have only one parameter, so that is 1 by root 3. So now you substitute and you tell the value for the star delta and auto transformer. So in the place of E, are you having E square as it is? If you are having only E2 squared, that is a D volt starter. E2 by root 3 whole squared, that is star delta starter. And the tap ratio into E2 squared, then that comes under the auto transformer. Okay, so you tell the value for star delta starter. That all the ratios represents what is the amount of voltage you are reducing during the starting condition. What is the percentage you are reducing? As per the given data, auto transformer we are reducing by 70%. Okay, but in the case of star delta starter, we are having a fixed reduction in voltage, so that is 1 by root 3.
Sir, K க்கு பதிலா 0.7 போடணுமா சார்?
ஆமா, இங்க K எல்லாம் வராது. இங்க நம்ம X K எல்லாம் கொண்டு வரல. ஆக்சுவலா ஆட்டோ டிரான்ஸ்ஃபார்மர் ஸ்டார்டர் இதுதான் ஃபார்முலா. ஓகேவா? ஸ்டார்டிங் டார்க் டு ஃபுல் லோட் டார்க் ஈக்குவல் டு X ஸ்கொயர்ட் ஆர் K ஸ்கொயர்ட் ISC டிவைடட் பை, இது ஒரு ஃபார்முலா இருக்கு. ஆனா இந்த ஃபார்முலா நம்ம யூஸ் பண்ண முடியாது. Why means this short circuit current is not given, full load current is not given in the formula, slip is not given in the formula. இதெல்லாம் கொடுத்துருக்காங்களா? ஷார்ட் சர்க்யூட் கரண்ட் கொடுக்கல, ஃபுல் லோட் கரண்ட் கொடுக்கல, ஸ்லிப் கொடுக்கல. ஸோ அதனால என்ன பண்ண முடியாது, இந்த ஃபார்முலா யூஸ் பண்ண முடியாது. ஸோ அதனால என்ன பண்ணியிருக்கோம், நம்ம இந்த ரெண்டு ஃபார்முலா யூஸ் பண்ண போறோம். ஸ்டார்டிங் டார்க்கோட ஃபார்முலா, ஸோ மேக்ஸிமம் டார்க்கோட ஃபார்முலா. ஓகேவா? அப்புறம் ஃபுல் லோட் டார்க்கு வி கால்குலேட்டட். ஓகே, ஸோ வி ஆர் கோயிங் டு டேக் த ரேஷியோ பிட்வீன் ஸ்டார்டிங் டார்க் ஃபுல் லோட் டார்க், பிகாஸ் த ஷார்ட் சர்க்யூட் கரண்ட் ஆர் ஃபுல் லோட் கரண்ட் ஆர் ஸ்லிப் இஸ் நாட் கிவன் இன் த ப்ராப்ளம். ஓகே, ஸோ அதனால இந்த ஃபார்முலா யூஸ் பண்ணி தான் நீ கண்டுபிடிக்கணும். ஓகேவா? இங்க கே எல்லாம் எதுவும் வராது, கேன்றது கான்ஸ்டன்ட். ஓகேவா? இந்த கேன்றது வந்து கன்ஃபியூஸ் பண்ணிக்காத. உனக்கு அந்த கே வந்து கன்ஃபியூஸ் ஆகுதுன்னா யூ கேன் ரைட் த ஈக்குவேஷன் லைக் திஸ் ஆல்சோ. ஸ்டார்டிங் டார்க் டு ஃபுல் லோட் டார்க் இஸ் டைரக்ட்லி ப்ரொபோர்ஷனல் டு E2 squared R2 divided by R2 squared plus X2 squared. You can use this formula also. அது மாதிரி maximum torque is directly proportional to E2 squared divided by 2x2. So இதுல இப்படி போட்டீங்கன்னா உனக்கு கேவே வராது. So here the K represents only constant. Kன்றது வந்து இங்க கான்ஸ்டன்ட் தான். So in the voltage, what is the voltage? Rotor voltage. What is the amount of rotor voltage you are going to apply? You are going to apply full voltage or you are going to apply reduced voltage. The DO starter means we will apply the full voltage. Full voltage na will represents DO illa வந்து என்ன பண்ணுவோம், E2 squared வந்து என்ன பண்ணிப்போம், அப்படியே ரெப்ரசன்ட் பண்ணிப்போம். So in the case of auto transformer, we will represents percentage. What is the percentage given the problem? So this is the percentage we are reduce the voltage. So star delta. What is the percentage we are going to reduce? E2 by root 3 whole square. This is the amount of voltage we are going to reduce by using this starter. So other than equation E2 place auto transformer will substitute 0.7 E2 whole square. Star delta means will represent E2 by root 3 whole square. Okay, short circuit current and full load current is not given.
Sir, இப்போ ரெண்டுமே கேன்சல் ஆயிரும் சார். இந்த இடத்துல E2 ஸ்கொயர் வரும் சார்.
இதுல வந்து E2 squared வந்து you can cancel the E2 and root 3 வந்து அப்படியே இருக்கும். root 3 மட்டும் கால்குலேட் பண்ணு. You can cancel the E2.
Yes sir.
You can cancel the E2, no problem. E2 னா டைரக்டா கேன்சல் பண்ண முடியாது. இந்த E2 by root 3 போட்டுட்டு அதுக்கு அப்புறம் தான் E2 கேன்சல் பண்ணனும். root 3 should be present. I will tell the answer. அப்ப இது சால்வ் பண்றது எவ்வளவு நேரம் ஆகுது? டைரக்ட் சப்ஸ்டிடியூஷன் தான். இந்த E2 by root 3 போட்டீங்கன்னா மீதிலாம் சிம்பிளிஃபை பண்ணி சொல்லுங்க ஆன்சர். So in the E2 ஓட ஃபார்முலா வந்து ரெண்டு இடத்துலயும் சப்ஸ்டிட் பண்ண கூடாது. You have to substitute only during the starting condition. During running condition you will apply the full voltage. Okay, ரெண்டு இடத்துலயும் root 3 போட்டீங்கன்னா you will get wrong answer. Okay, so I write it here clearly. So starting torque to full load torque is equal to K into E2 by root 3 whole squared into R2 divided by R2 squared plus X2 squared into 22 divided by K E2 squared. இங்க வந்து E2 வந்து E2 தான். So this is the starting torque equation. This is the full load torque equation. So during the starting only we will reduce the voltage. So during running we will apply the full voltage. Okay. So this is the actual equation.
Sir, 0.143 sir.
Okay. Okay, answer 0.143. So இந்த கான்செப்ட் அண்டர்ஸ்டாண்ட் பண்ணிக்க. ரெண்டுத்துலயுமே E2 ல 1/√3 சப்ஸ்டிட் பண்ணிடாது. அதுதான் மறுபடியும் ரிப்பீட்டடா சொல்லிட்டு இருக்கேன். ஓகேவா? So this is the thing we are going to calculate starting torque to full load torque. You write the starting torque equation, you write the full load torque equation. And in the place of E2, in the starting torque alone, you have to substitute ET divided by root 3 because during the starting condition only we will reduce the voltage. And in the full load condition, you won't reduce the voltage, you will apply only the full voltage. Okay. So in this E2, you should not do anything. Okay. The starting torque alone you do, then you will get this answer. So it will be around 14.3%. So similarly, you tell for the auto transformer. So in the auto transformer also, you have to use the tapping only for the starting torque equation. So in the 0.7 is clear. So in this 0.7 into E2 squared, you have to substitute only for the starting torque equation. In the full load torque, it should be E2 only, E2 square only. And you tell the auto transformer starter value. உனக்கு எதாவது கன்ஃபியூஸ் ஆகுதுன்னா கேளு, டவுட் அந்த கேளு. So we'll solve this.
Sir, full load torque ல வந்து 0.7 போடணும் சார்.
full load torque ல போட கூடாது. எல்லாமே ஸ்டார்டிங் டார்க்ல தான் போடணும்.
எஸ் சார் ஓகே சார்.
ஃபுல் லோட் டார்க் வந்து E2 தான் இருக்கும், E2 ஸ்கொயர் தான் இருக்கும். நம்ம எங்க வந்து வோல்டேஜ், அதாவது நீ வந்து ஃபார்முலாவை மக்கப் பண்ணாம எந்த இடத்துல வந்து வோல்டேஜ் குறைப்போம்னு பாத்துக்கோ. ஸ்டார்டிங் டார்க்ல குறைப்போமா, ஃபுல் லோட் டார்க்ல குறைப்போமான்னு பாரு. ஸ்டார்டிங் டார்க்ல தான் நம்ம வோல்டேஜ் ரெடியூஸ் பண்ணுவோம். அதான ஸ்டார்டிங் மெத்தட். ஸோ டூரிங் த ஸ்டார்டிங் கண்டிஷன் வில் ரெடியூஸ் த வோல்டேஜ். ஸோ ஒன்ஸ் த மோட்டார் அட்டைன்ஸ் இட்ஸ் ரேட்டட் ஸ்பீட், ஸோ வில் அப்ளை த ஃபுல் வோல்டேஜ். ஸோ தட் இஸ் த கான்செப்ட். ஸோ இந்த ஸ்டார்டிங் டார்க் யூ அப்ளை 0.7. இந்த 0.7ன்றது வந்துன்னா திஸ் த ரேஷியோ. இஃப் ஹியர் இவங்க ஒரு 100 வோல்ட் இருக்குன்னு வச்சுக்கோ, 0.7 into 100னா 70 வோல்ட். இந்த 0.7 இல்லைன்னா என்ன ஆகும், யூ வில் அப்ளை த ஃபுல் வோல்டேஜ். ஓகே. ஸோ டூரிங் த ஸ்டார்டிங் கண்டிஷன் வி ஆர் அப்ளைட் 70 வோல்ட். டூரிங் த ஃபுல் லோட் கண்டிஷன் வி அப்ளைட் 100 வோல்ட். ஸோ 100 வோல்ட் அப்ளை பண்ண பிறகு இங்க ரேஷியோவே வராது ஃபுல் லோட் டார்க்ல. Tell the answer for auto transformer starter. So this is for star delta. Auto transformer will, if you write this same expression, so starting torque to full load torque is equal to K into 0.7 into E2 squared R2 divided by R2 squared plus X2 squared into 22 divided by K E2 squared. இவ்வளவுதான். $42. Any வேற ஏதாவது ஆன்சர் இருக்கா? Venkateshan, kindly check the answer. உங்களுக்கு வேற ஏதாவது ஆன்சர் கிடைக்குதா? 0.426 இல்லாம வேற ஏதாவது ஆன்சர் இருக்க பாருங்க.
Sir 0.1220 sir.
0.1 0.1220 இல்ல, அந்த ஆன்சரும் இல்ல. வேற ஆன்சர் வருதா? வேற ஏதாவது? எனி அதர் ஆன்சர்? அது 0.7 E2 ஹோல் ஸ்கொயர்டு. அது வந்து 0.7 எடுத்துக்காதீங்க. 0.7 E2 ஹோல் ஸ்கொயர்டு. 0.7 ஸ்கொயர்னு எடுத்துக்கணும். E2 கேன்சல் ஆச்சுன்னா. எனிபடி இஸ் கெட்டிங் 0.213 213 ஏதாவது வருதா பாரு. This is 21.3% jerk வருதான்னு பாருங்க, செக் பண்ணுங்க.
சார் வருது சார் 0.213 சார்.
எஸ் சார், அதான் கரெக்ட் ஆன்சர்.
சார் 22/√3 போடாம இருந்தா கரெக்ட் ஆன்சர் வருது சார்.
22/√3
போடாம இருந்தா கரெக்டான ஆன்சர் வருது.
√3 இங்க போடக்கூடாது, நாங்க தனியா எழுதிருக்கோம் பாரு.
அந்த e2
√3 இங்க வரவே வராது. ஸ்டார் டெல்டா ஸ்டார்டருக்கு மட்டும் தான் √3 வரும். இப்ப நம்ம வந்து ஆட்டோ டிரான்ஸ்ஃபார்ம் ஸ்டார்டர் தானே சால்வ் பண்றோம். ஆட்டோ டிரான்ஸ்ஃபார்ம் ஸ்டார்டர்ல √3 வராது.
எஸ் சார்.
அதுக்கு தான் 0.7 போட்டிருக்கோம். ஆட்டோ டிரான்ஸ்ஃபார்மர் வந்து டேப்பிங் கொடுத்துருப்பாங்க, 70% டேப்பிங் கொடுத்துருக்காங்களா, அதனால 0.7 E2 ஸ்கொயர்டு அவ்வளவுதான். ஸோ √3 வந்து ஒன்லி ஃபார் ஸ்டார் டெல்டா ஸ்டார்டர். ஸோ செகண்ட் சப்டிவிஷன் we are solving for auto transformer. Auto transformer starting with tapping of 70% அப்படின்னா அங்க √3 எல்லாம் எதுவுமே போடக்கூடாது. So directly got to substitute 0.7 into E2 whole square. So further are you having any doubt? இதெல்லாம் வந்து ப்ராப்ளம் கண்டிப்பா வந்து CA2ல இருக்கும். ஸோ ஏதாவது டவுட்ஸ் இருந்ததுன்னா கிளாரிஃபை பண்ணிக்கோ. ஸோ கரண்ட் கொடுக்காம சால்வ் பண்ண சொன்னாங்கன்னா இது மாதிரி சால்வ் பண்ணும். யூ ஹேவ் டு சால்வ் லைக் திஸ் மெத்தட். இஃப் இட் இஸ் கரண்ட் இஸ் given, so ratio between starting current to full load current, so current is given means you can go for what are the problems we solved previously with respect to short circuit current. So number example 6, 7, these two problems comes under short circuit current. Okay, short circuit current is like கண்டுபிடிக்கிற மாதிரி இருக்கும். ஓகேவா? So here it is given starting current is 6 times the full load current. If it is given like this means you can go for starting torque to full load torque equal to short circuit current divided by full load current whole squared into slip. You can use that formula. And if in terms of current it is not given means it is given like this. So for this case you have to use this starting torque maximum torque formula, then you have to calculate the full load torque. And then if the starter is given means you have to go for like that. In the place of E2 squared, either you have to substitute divided by √3 whole squared or in terms of tapping. So ரெண்டுமே வராது, டேப்பிங்கும் √3யும் ரெண்டுமே ஒரே ஈக்குவேஷன்ல வராது. It is varied based on type of starter. If it is a star delta starter, so you will get 1/√3. And if it is auto transformer starter, you will have the tap ratio. Okay, so ratio into E2 squared, that is whole squared. So you have to remember this. Okay, you should not confuse. If மாத்தி போட்டீங்கன்னா you won't get the answer. Then E2 squared at √3 where you have to put, either you have to put in the starting torque equation or flow torque equation. That also you have to remember. So that E2 represents either you are applying full voltage or you are reducing the voltage by factor √3 or you are reducing the voltage in terms of number of turns. Okay, that will be varied based on type of starter. And if it is a D-oil starter, you will have only E2 squared. And if it is a star delta starter, you will have E2 divided by √3 whole squared. And if it is auto transformer starter, so you will have tap ratio into E2 whole squared. So the auto transformer starter and stator resistance starter will be almost same. You will have the similar equation. Okay. So with this we wind up the class. So we'll continue with the some more problems on tomorrow class. We have one theory topic. Then after finishing that theory, we'll continue with the additional problems in the starters as well as in the torque equations. Okay. Okay. Further, if you're having any doubt, means you can ask in tomorrow class. So now it's almost 3:30. So you'll have unit test, I think. So you can carry out the unit test. So any doubts you have, tomorrow morning we'll discuss. Okay, thank you.